guys can hear me okay. Let me know. I still can't believe this OBS actually. Hi everyone. Hopefully you can hear me okay. Just fire a quick message in the chat if you can hear me. I cannot believe how absolutely bonkers this is, that it's absolutely maximizing every bit of my CPU usage to do streaming, but not for recording video. So sweet. I get it now. Okay, so what do you guys want to be hitting up? I'm assuming we'll do Visual Studio. So let's hit Visual Studio up, and hopefully it's not going to crash my computer. And let's figure out what is potentially confusing some of you. So let's do I already have strings? I already have a strings demo. I don't want to give you my solutions to various strings. Oh, that's an old one. Okay, I'll open it up anyways. And please, if you have questions, let's post questions right now, and then we can always go back. I can adjust on the fly. What I don't want to do is find out like, oh, I didn't answer your question. I'm assuming you have questions about strings, but if you don't and you want to ask questions about other stuff, I'm more than happy to go over some of those other things. I actually have a string demo that I can just play around with. All right. All right. So let's see. Does anybody have any questions before we go about what we're doing? We're trying to do? I found the first assignment. It was open the text file, the debug folder, and I wasn't sure how to change the path. Oh. Hopefully you guys are not seeing a horrible experience on my thing. So what you're talking about is if we have a resource file in here, let's say make a new one, add a new item, and let's see here, utility text file. My sample text. I can't spell sample correctly, it seems, but that's fine. Let's have a look at where the heck this thing is. What it's going to have, so let me get ahead of things a little bit. You'll notice that in class code, L04 demo, in the L04 string demo, essentially exactly where my string demo.cpp is, in the exact same folder, is my simul text. It should be my sample text. My simul text is in the exact same folder. And when I'm running from Visual Studio, that's where it's looking. We also do on, I think, one of the labs, we try and do it from the command line. And when we do it from the command line, it looks in a different path. So what will end up happening is I can go to a different path, but if I'm running from Visual Studio, it looks in the same place where my CPP file is. And if it's going from the command line, it's looking where the exe is. It's looking in the wherever I'm running things, and it's sort of running from stringdemo.cpp. Otherwise, it's running from where the exe file is located. And that's actually what's happening with for finding it. So your question was, how do I find it if it's open the text file from the debug folder? And I wasn't sure how to change the path. You could change. The easiest thing to do, honest to God, I wish I had a better solution. I really wish I had a better solution, but but I just copy the same text file, put it into two different places. It makes your life easier. You can test it a lot faster. So I put it where my CPP file is, and I'd also put where my exe file is. That's not the actual proper solution. The proper solution is to figure out what the actual file path is, get the actual, local file path at any given time, and have some kind of logic to deal with the different ways that where the file path could be. But let's have a quick look at the second half of the assignment for this, which hopefully will also directly deal with what we're going to be dealing with in the for the next assignment. All right, so here's I'm going to have this file. I'm going to make my sample text. This is my sample text here. I can find all the current Differences of everywhere. Seriously. All right. That's going to be my text file. Why? Because why not? Okay. So first up, let's read in that file. So I need to read in a file. That's great. Here's the old school. So I have a bunch of old school ways of doing things. Let's read in a file. And what I want is I have a file and P my example, and I'm going to, I always got to look it up every single time. What I want to do is open my file, and I always, I have a really faulty memory. We should actually even have an example of me reading in a text file in here somewhere, I do believe. And if I don't, I'll just have to read what it should be. Fopen, that's what it is. Fopen, autocomplete to the rescue. I have a file name, and so I'm going to put in whatever file name it's going to be. So my SAML text.txt, and the mode is going to be R for read mode. Okay, and fopen should, it's going to return a pointer. So P my example is equal to that. And then what I need to do is check to see if it actually opened up properly. So if P, I could say if it's equal to null, or not equal to null, that's, or I can check to see if it's, let's check to see if it's equal to null. So I know I did not read in the file correctly. I want some kind of printf statement saying, holy crap, bad things happened. Printf, println. Holy cow, the file didn't open correctly. All right, and I want to get out return 0, or like return -1 for an error. All right. That's if the file doesn't open correctly. Then I need to, okay, now that I've opened the file correctly, I'm going to need to read line by line from this file. This is something that we covered, I'm pretty positive, and if I didn't, you should have yelled at me. We go over it briefly in the review lectures, and then we're also going to we're going to talk about it even more in the lectures on strings, which you should be looking at right now. Not right now, but this week. So fscanf, and I want to use I'll use a safe version of fscanf. I'm going to read in from a file, so I need to P my example, and I need a particular format. It's going to be reading in a string, so the particular format is it's a string that I'm going to be putting it in, and I need to stuff it somewhere. So A2 test 2 would be perfectly fine. Yeah, that should do it. Right? So what's this going to do? It's going to get from this file the next available string up to a white space, and then dump it into this array. This thing also has, I do believe it has a parameter for the size of the array, and I'm going to forget the name of the syntax, so I'm going to find out the hard way. I know fscanf, not fscanf_s. This _s added an extra parameter. I don't know what the parameter is. Find out. Doesn't hurt to find out. Okay, so let's compile this thing. Let's not try and go much further. fopen_s. Sure. And what does this thing take in? Oh, it's going to take in my file. That's what the difference is. All right, and it's going to take a pointer to my pointer, because I need to change my pointer. And I can still do what I was doing before. fopen_s will also return some kind of error message if there's an error. So that's something nice about it. Let's have a break. Let's break this. Actually, let's see. That's the kind of mistake I'd make. I'd spell the file name wrong, and then I'd use the wrong name. Okay, let's compile it again. And let's see it fail, hopefully, miserably. And we'll put a breakpoint here. And broke miserably. Great. I know I have a problem. So I can look at what the heck it's trying to open. I can look at the example. Oh, my example is equal to null. Why is it equal to null? And then I'm going to look at, like, why did it go wrong? Oh, maybe because I know now. It's because I spelled this thing wrong. But you go line by line, and you do a little bit at a time. There is no reward. There is no prize for writing all of your code all in one go. So if it wasn't in that directory, I would also get the exact same error message. Now that it's found the file, I'm getting this. I'm going to the correct location right here. Okay, so this is going to take one string from this file, and it's going to stuff it into A2text2, or maybe it's not. I'm going to find out the hard way. Did it work? And let's see what A2text2 has. This. And I'm going to look at my string and see this. Great. That's what fscanf does. So I didn't know if it was going to work. I tested it out. I see that it's working. Great. Move on. Instead of fscanf, let's try fgetS. And then I'm going to take in my character buffer, A2 test 2. I didn't memorize it. I just put stuff down, and so str buff size. Hell, I will say I can only do one less than the file, just in case. I know I need that extra little space at the end. I need that 0 at the end of a string. So let's give myself an extra character in that buffer, just in case. Probably won't. Hopefully, I won't even come into that. Coming to need this. Okay. And I needed one other thing from this, so I'm going to hover over this and say, oh, I need the file stream. Okay, so p my example. All right, this should get a full line of text. And that should be a comma. Okay, great. And I want to see what this thing does, because, you know, I don't remember these things. I do, but I want to show how I don't remember anything. All right, I'm going to go one line down, and I'm going to see what I get here. This is my sample text here, exclamation point. Great. If I wanted to find a particular character from the string, let me check to see if there's additional questions right now. But if I wanted to find an additional character in that string, there are functions for me to use. So I could do something like this. So str. If I want to use a string comparison, I'm going to use A2 test 2, and I'm going to say the thing I'm looking for is exclamation point. It's one character, but it could be a string. I could also do strchr. It'll be the exact same thing. Let's do. In case you're wondering how I knew this, I looked it up online at some point in time. And it's just, you do this enough, it'll stick in your head. So here is a string character, very original name, strchr, string character, str, string, right? strlen, string length, str, and you can just start typing in str and see what you get. Str, length, copy, string, number of copies, I can string copy. I can, yeah, those are the other ones. And let's see what other things I want to do. str. There's one other one that was concatenate. I don't think concatenate's in there. What could I do? I want to, strcmp. String compare. So we have string compare. I'm going to just put a comment in this. I have strlen, another useful function. I have strchr, let's see what other things I have. Str and cpy. That is copying a certain number of characters over. They're all useful functions. right? But I don't try and remember it. I just put str and see what happens. What do I got? It gets even better when we do objects. So let's see if you have questions while we're doing this, and then I'm going to go back to this in a second. The -1, I'm just being paranoid. It probably will not affect us in any way, shape, or form, but the -1 was, I know I need a 0 at the end of that buffer, and I don't exactly know how fgetS actually works. I don't know if it's automatically going to assume that I have that extra character in there, so I want to make sure I'm not going all the way to the end of my array. The worst thing I could do is overflowing the end of my array. So I have 100 characters. Let's say I have an array of 100 characters. You type in a message that's exactly 100 characters long. Is it? If I have a string of 100 characters long with a C string, I have a 0 at the end at position 100. 0 to 99 is my string, so 100 characters, and there's a 101th character needed. I need a 0 at the end. That tells me I'm at the end of my string. That's how I indicate that. So what I want to be able to do is just like make sure I'm not going outside of my array. Even if I have one less character, I'd rather that than go outside of my array bounds. That's just me being paranoid. Yeah, that's exactly right, Elijah. Thank you. So this is me. I'm going to get what I'm doing here is I'm looking for a particular string. That string is exactly 1 character long, just the exclamation point. It would be the same as looking for strchr. Okay. By the way, how long is this string? Despite the fact it looks like 1 character long, the amount of memory required to store that string is 2 characters long. The exclamation point and the 0 at the end of the string. So even nothing, like if I have a quote with nothing in it, it's still 1 character long. It's a 0 at the end of the empty string. It's how we tell the end of a string. You see it again and again. Everything is some string. So let's put, so I could do this. If let's do an example of this. CHR, a test, at position, and let's make it size 10. And I want to have a test at position 0. I might want to do this some kind of better way, but C D 1 2 3. All right, and then I'm going to put a position, this position, I'm going to put a 0 at the end. Okay. And then I'm going to put a breakpoint just to show you this in action. And then I'm going to put a breakpoint, and then I'm going to put a test at position, let's say 2, and then I'm going to make that equal to 0. In case any of you are not believing me, notice this is not the number 0. I'm not putting, let's put that in there as well. 4 5 0. This is just me doing an aside here, just a little demo. Okay, I'm going to move down my thing. All right, I'm making a character that a character array with nothing in it. Notice it's all these eyes. It's just filled with whatever garbage I had around. I'm then going to set my various characters. A with a bunch of garbage afterwards. B with a bunch of garbage afterwards. C with a bunch of garbage afterwards. D with a bunch of garbage. 0 with a bunch of garbage. A, B, C, D, 0. How do I know the end of the string? There's a 0 at the end of the string. This exact kind of 0. This means the number, the numeric number 0 in there. Not the character 0, not anything else. It is actually a 0. But we use this to say, like, no, I'm serious. It's this character 0. I didn't make a mistake. I didn't accidentally put like a null pointer in here. I didn't accidentally do some weird math. I want 0 here, and that's why we use that /0. It's very clear that I didn't accidentally do this. I intentionally said, no, there is a 0 here. Okay, so this is what I get. A, B, C, D, 0. And let's go one more step. The next step is I'm going to just replace position 2. Instead of a C, I'm going to put a 0 at that position. And let's see what happens. Instead of A, B, C, D, 0, what do I get? I got to go back and look at what I get. A, B. What? I replaced the C with a 0, and it says that's the end of my string. After the B, there's a 0. It's the end of my string. It allows you to have this, you can have an array of 4 billion elements. You only use the first 5. You can see a 0. That's the end of your string. It allows you not to have the same array size as the length of your string. So you can play around with it a bit more. You can have this giant array and only fill it up halfway with text. It's a lot more convenient in terms of how you go about programming some of this stuff. All right. So that is us using the 0 in here. I'm going to just comment out this big block of code. I'm going to save this one, and I'm just going to comment this big block of code out. Yet another demo, and we're going to move that down here. Oh, I want to move it below there. There you go. There's nothing. So I'm going to look for the exclamation point. And maybe I want to do something with the exclamation point. Like when I find it, I start searching for other stuff afterwards. That's what you're doing in the assignment. You're looking for, let's say, the start of a comment block. And then you'll be like, hey, I'm in a comment block now. Everything after that point is a comment, and I can just remove it. I can remove it by just putting a 0 wherever the heck that thing was, or ignoring certain chunks of code, right? If I need to get rid of the rest of the line, put a 0 there. I've gotten rid of the rest of the line, or I just don't copy anything over. So this putting a 0 in can be really quite useful. So if I have a to text 2, for example, and I just drop down a 0 in that thing, it is an empty string. There is nothing. I still have the array, but the string, there's no text in the string. Or maybe I only go halfway and then change the value. It'll still be, so what I'll do is fgetS does what? It's going to return some kind of error message. This thing will be putting it in my character buffer. It gets me that particular stream. I always figure out what the fgetS, what this thing spits out in the end. It'll also set the value for this, if memory serves me correctly, but let's find out. Okay, so, it's going to give me a character pointer. There you go. If I look at the front of this thing, it says it returns back a character pointer. So, p my new text. All right. So what I could do is not if and only if p my new text. So if I have a valid array, I'm going to look for the exclamation point. I'm going to look for that exclamation point. Exclamation point, so X pause. All right, I'm going to look for the exclamation point. If p EXC pause, and then I want to see what I can do with that. So this is just going to point to, and let's have a look at this one. We'll see what we'll put a breakpoint in here. All right, does not equal null. What do I do? If this thing is not equal to null, well, let's actually just stomp on what its position is. So I could let's do it the fairly simple way. This is a pointer. Wherever this thing is pointing to, set the value, not null, I want to set it to the character 0. It's the same as null, but I want to set it to the character 0. Okay. And then I will get a new line. Again, rinse and repeat. And then I'll make this a while loop. So if I get when I call fgetS, if I get something, I'll get a character pointer. That's what this thing returns. That's how I know if I got jack squat. I will get a character pointer. If that character pointer is not null, I can look for an exclamation point and then set the value to 0. And what that's going to do is truncate my string. And then at the end of the day, let's do this. I want to do it line beforehand. I want to do print f the new message. And then I'm going to put a string and a new line. And then I'm going to A2 test 2. So I'm just going to print out the message I had. So this thing is going to get a message with fgetS. It's going to go into here. I'm going to find the exclamation point if there is one. If there is one, I set whatever the exclamation point is to 0 now to truncate and end my string. And then afterwards, I'm going to print off what this new message is, and I'm going to get the next line of the string. I should keep going until there are no more lines of text to get, and each time I'm going to spit something out. Okay. So I'm in iteration number 1. This is my sample text here! Exclamation point. I can look at what p-exec exclamation point position is. It is this exclamation point. Notice the address 8FFBB7. Let's look at this address 8FFB9C. It is pointing to some part of this original text message. This array, this chunk of data, it's pointing to one of the parts of that chunk of data. So it's pointing to an exclamation point. It's actually exclamation point at the end of the line. So let's actually have a look at what's going to happen next. So I need to move this down. I'm going to, if it's not equal to null, it's not equal to null, I'm going to replace the exclamation point with a 0. And this is my sample text here, no exclamation point at the end of my string. I output that message. I'm going to get the next line. The next line is, I'm doing it, I think I need to do it, I'm doing it twice each time. Unless I have a new line in here. Let's have a look. So there is no exclamation point. I move on. New messages, nothing at all. I get the next line. I can find all occurrences of, all right. And exclamation can find all occurrences of something. What the heck? That should have found that exclamation point over here. That's why I'm finding it a little weird. Oh, am I not in there yet? No. Oh, that's the new line. That's the next line. There we go. So I'm finding where the exclamation point is. Can find all occurrences. I then remove I'm going to stomp on that exclamation point. And the new message is going to be, let's have a look at the message. I'm going to keep on going around a couple more times. Everywhere. Okay. Okay. Seriously. Getting rid of everything after the seriously. And it's the end of my line. That's the end of the file. And now I'm doing the rest of this. Let's have a look at what this message spits out. The new message, this is my sample test here. The new message, sir of seriously. And let's have a look at what the message itself was. And it is, I blank can find all the occurrences of blank everywhere seriously. There's something weird going on. Where's the ser of? Sample message here. There's a new extra line in here which does a carriage return. Where's the CES? Occurrences. It only went up to a certain point. Let's have a look at how many characters that must be. That's really interesting. Okay, let's have a quick look at my code. Let's string demo. Let's stop it. I noticed that occurrences was somehow truncated somehow, and I'm wondering what the heck happened. So let's have a look. $30 characters. That's why. It turns out if I go fgetS, it will only get up to a certain point. If it's over 30 characters, it's going to stop it. Oh, so why am I using a constant here? Let's find out. All right. Everything works. That's why we use constants, by the way. Because if I use a constant, if I use like a constant like this, instead of putting the number 30 everywhere, if I replace it in one place, it'll replace it everywhere, and everywhere it will work. I'm going to make a string buffer of size 300, 300, 300, and everywhere string buffer size was located before, instead of 30, it is now 300. And everything now should now work. I don't hard code values. Okay, so let's run this. And that's why we had a weird incident. Oh, maybe there's something weird going on. Can find occurrences everywhere. I think we have a problem here. Let's hold on. Oh, no, that was fine. This is a sample test here. Seriously. What would I expect to see? This sample text here, without the exclamation point. Stop after there, before the exclamation point. Seriously, get rid of that. And I was able to debug my code based off figuring out, oh, the output message looks a little weird, and then I have to backtrack and figure out what could be causing that. Oh, the size of my array buffer was just too small. Okay. Let's see how people are doing. Okay. You do need to leave room for a null pointer. It's a null terminator, which is the 0 character at the end. The non-printable 0. It is a null, which is a null terminator, which is at the end of the string. It comes to string arrays. String arrays, an actual string object, Danielle, does all sorts of things for you. They'll do your taxes for you. Like, they'll do everything for you. So that's why that's why a lot of people love strings, because they handle most of the things like the 0 at the end. Initialize the array to and Elijah, you've been using Java too long. Why doesn't it all initialize everything to 0? Because it's C. And C and C++, in their infinite wisdom way back in the day, said, you know what? That would take time to initialize everything to safe values. So we're just going to leave you whatever crap was there. That's why malloc works the way it does. Malloc is just take some array memory. Not going to set it up, not going to clean it. You get whatever garbage someone left behind. Honest to God. That's why a lot of languages nowadays go, no, we're going to initialize it. Because it kept on biting people in the backside. But I shouldn't say it is what it is. I sound like Trump here. It's what it is, the nature of C and C++. It was designed a particular way, and people like that. they like it like that, essentially. So 0 is informing us that we're nearing the end of the array. You are at the end of the array. Nice. So the end of and the null wasn't sure if it was a 0. So the reason I don't say the word null is because null also means a pointer null, which is, it's a whole thing. Yes, so Elijah, that's exactly right. The 10 says, you will give me an array of 10 elements. The curly braces says, what do I put in those when I'm starting up things? If they do not match up, if I use the curly braces and I use the square brackets, if I put 10 items in the curly brace, I better have a 10 in those square brackets. Otherwise, I get an error. I also never got into the habit of putting things in the curly braces, so I probably should have done that for my example. You are absolutely right on that one. I didn't even think about that. I'm so used to just line by line afterwards initializing everything I forgot all about, yeah, just put it in curly braces and that would have done the trick. So that would have been a much better solution. Are we going to be using both C and C++? No, only the start of the course. It is a compare and contrast. The assumption, and I know it's not a true assumption, the assumption is everyone took 1400, you passed the prereqs for 14, you passed 1400, so you got the prereqs for the class, and I realize it's not always the case, but it's what we have to work under. And therefore you know what, C and procedural languages look like. Now that we've done that, let's twist it around and look at it from a different perspective. Let's look at object-oriented programming. And so we're in the transition right now. Assignment 2 is, here's what a C string version of this program looks like. Here is a C++ version of this program. That's what this thing looks like. Okay, now that we've done C++ strings, now let's actually make our own objects. So it's this iterative, step-by-step process of introducing what the hell an object is and what it means. And some people go, why are you going so slow with it? Because I will still have people not understanding objects by the end. So I like taking my time with that just to get people's heads around the idea. Okay, in the assignment I don't quite understand how to use malloc and calloc and a bit using arrays of structs. Okay, let's make a malloc and a calloc. All right. So instead of this, let's do a malloc. So char, notice A2 test 2 is, I overly emphasized, it is what we get out of this thing is a pointer to this chunk O memory. That's all it is. This A test 2 is not actually this array. It's a pointer to a chunk of memory. That's what C actually is doing under the hood. We're going to do something very, very similar. It's going to be almost exactly to test 3 and is equal to, I'm going to be a char pointer. I have to cast something, meaning, no, it's not a void pointer. It's a char pointer. This is going to give me the exact same thing as A2 test 2, other than the fact it's dynamic. Size of char multiplied by, and I'm going to use this str bit. It acts, looks, and behaves exactly the same as the other array. The only difference is I need to clean up this array afterwards. So let's do, everywhere I have a test 2, I'm going to put in a test 3. Test 3 should make no difference to anyone at any time. Test 3, there you go. Oh, I have to one more thing for test 3 though afterwards. Free, and put that in there. I need to free the memory. And after that, I need to do one more thing. I don't have to, but I should. The reason I need this thing, I say it in the videos, but I want to emphasize this. How do I know I've freed up the memory? If your memory is as bad as mine is, and hopefully it's not, but some of you it probably is, you have 4,000 lines of code or whatever the case is, you free the memory in one place, you forget that you freed the memory somewhere, and then you go further down and go, oh, I better free that memory, and you call free again, and it will blow up in your face. And the only way you know you've already freed it, I don't know if I've already freed it. It's going to still point, we're going to see that it's still pointing to the exact same thing as it did before. So let's put a breakpoint in here. It's still going to point to the exact same position in memory. Some other process will go and take that memory and do all sorts of stuff with it, and you're still pointing to that chunk of memory. The metaphor I like to use is, when we sold our house, we gave away our keys, right? If we kept a copy of our keys, it means we can go back to the house that we sold to somebody else and just start walking in the door, right? Nobody wants that. Once you give away your keys, you got to get rid of, once you've given away your house, you got to give away your keys, right? That is this thing here. I'm saying, no, I'm pointing at null now. I'm not pointing to this chunk of memory because I don't own it anymore. I got to make sure I don't think I own that chunk of memory. Otherwise, in release mode, it will merrily let me stomp on other people's memory. I'll have some other process on my application, and I'll just go merrily stomping on it without a care in the world. And you won't find that problem until about 3 months later, you'll be having your code, it'll be running stably, and then, like, 4 hours later, the entire program crashes, and you don't know why. It's because there's this other process just merely stomping on memory, unaware that it's not under its control anymore. It is a bad situation. Those are brutally hard to find. So, when you're done, set it to null. Just get in the habit. You don't want to learn this lesson the hard way. Okay. When you're done, set it to null. Just paranoid. Set it to null. Okay. So let's see this in action, because it should make no difference. Okay. And my message is exactly the same as it was before, despite the fact I have a dynamic array of memory, but it's doing the exact same thing. This is saying, get me this many bytes of data and make a character pointer to it. This is a character pointer to that many bytes of data as well. The only difference is this cleans up automatically by itself, because it lives here and dies as soon as that function ends. This thing is, I grab it from the system dynamically on the fly, and at the end of the day, I have to manually give it back. It's like me taking a library book out. If I don't give it back, they're not coming to my house to take it. I got to go back to the library and give it back. Okay, so let's have a look at what the heck this is pointing to. A2 test 3. I'm going to go one step down if I can see my keyboard here. And it is still pointing to what it was pointing to before. It now has a whole bunch of gobbledygook in it, but it's still pointing to exactly what it was pointing to before. And now I set it so that it's now pointing to null. So I can check, hey, have you been freed? Are you equal to null? If you are, I know I've freed you as memory. If I don't see it as null, I know I still have control of that memory. It's a locking system. It's, how do you know you've turned off, that you've locked the keys? Well, maybe you have some little ritual where you put their keys somewhere in the house and you haven't locked the door unless you put the keys away, or whatever ritual you have, right? To remind you. It's like tying a string on your finger, right? If I set it to null, I know I've freed that memory. If I don't have it null, I know I have not freed the memory. Okay. One more. Let's do a calloc, and I won't even need to change anything. Let's move this over. Okay, char pointer, calloc, and then it will be size of char, and then there'll be str. There we go. The differences between calloc and malloc, and so this is the size, and so it should be the other way around. It won't make any difference whatsoever to what we're doing, but this is, how many things I'm going to make, how big each item is. That's why we have the multiplication. It is, each character is 1 byte, and we have 20 characters, so 20 times 1. If I have 20 integers, it's 20 times 4. That's all calloc is going to do. And let's also put a breakpoint there on my calloc. The only difference between calloc and malloc, here it is. Watch the birdie here. Maybe you won't even see it. Hopefully you'll see it. A2 test 2 is equal to quotes. Wait, that's an empty string. Why is that an empty string? Because calloc, unlike malloc, when it gives you the memory, it cleans it up first. This is like the turn down service, the fancy pants Airbnb, or whatever you want to call it. It is the fancy version of malloc. It's malloc that cleans up the memory for you before you use it. That's the only difference. There's a slight syntax difference because I use a comma instead of multiplies, and it cleans crap up. Nothing else changes. Even the free operation, exactly the same. So I can get rid of that, run it, get rid of that, and I should be fine. Moving on to the next part. Let's just see it in action. Whee! All right. There is no difference. All right. That line 68 is a pointer. All right. Let's have a look at line 68. I don't know my 9 numbers necessarily offhand. Oh, literally, this is an array, right? But under the hood, what's happening is A2 test 2 is actually, without you knowing it, is actually just pointing to the chunk of memory. A2 test 2 acts like a pointer. You can dereference it just like a pointer. So I can say A2 test 2 and go at position 3, which we've already done. But that's pointer arithmetic. That's what we've been doing before. I can do is equal to the character 0, same as we did with the pointer. It doesn't yell at me. It doesn't get mad at me at all. A2 test 2 is a static array, but really the actual variable A2 test 2 is just pointing to the front of all this memory. So it looks, acts, behaves exactly like a pointer, even if we call it an array. It leads to all sorts of weird things, right? C and C++, it's so old school that it's very, very upfront at what's happening. You're saying it's not an array, it's just pointing to the front of a chunk of memory. And you sort of have to know that all these things are equivalent to one another. In Python, they hide all sorts of things, and rightfully so. A lot of the complexities that you don't really need to know about. But C just puts it right up front for everyone to see, which is the joy of C. Okay. Oh, you don't even see on camera, so you're not even seeing all of my hand symbols and stuff like that I'm doing here. How many people enrolled in the course? 96. Thank you. Probably 42 now, and maybe a little fewer. I'm joking, but at the same time. So I wish I had the hair of Bob Ross. I really do, Elijah. The code is available to you, so I'm not expecting you to type it. You should be following along, watching what I'm doing, not necessarily typing along at the same time. It doesn't initialize the array to 0 because, well, it was just a chunk of memory. So it doesn't necessarily know you want to initialize it all to 0. And in its infinite wisdom, C doesn't necessarily set everything up for you. It's kind of fun that way. Yeah, it's the nature of C. They don't. If it's going to save you 2 CPU cycles, they will do it. So a lot of these things are, they still have go-to statements in C, right? Like things you should never do, because it was going to be slightly faster to do it that way, and therefore you have the option to do that slightly faster thing. And there's all sorts of decisions that they make. That's why games are often made, or used to be exclusively made, in C and C++. C++ oftentimes, right? Because it was fast. It let you screw up all sorts of different ways, but it was fast as hell, right? Java has all this overhead in terms of processing speed and being able to handle things. C is fast, but it means you screw up all over the place. There is no, I guess it might be like driving a Ferrari, right? You can go really fast. You can also kill yourself with it, right? Going fast is not necessarily the best. If you're just learning to drive, you do not want to be driving a Ferrari, but it is one of the most applied of the languages, and that's why we're learning it here. It is not the nicest to beginners, and I fully admit that particular fact, to the point that a lot of schools will go with functional languages and things you would never use again, but because it helps you get the mental model. See, it's all these little minutia and details in there, and it makes it very intimidating, very challenging, and it makes output syntax and stuff like that a pain in the ass to try and read. But it is the one thing that every single one of the degree programs in the BIT program, every person, every group in the school, they all sort of agreed, like, yeah, our students need to know C or C++. And as a result, it meant that we had a sort of standardized set of courses for all students in the school, whether you're doing the NET program, or you're doing IRM or IMPD or BMPD, IMD, whatever the case is, right? It was a standardized approach, but it's not gentle. It's necessary skills later on, but doesn't play nicely, and it's unfortunate that we have to sort of teach you the hard way by pain and suffering. I don't want it to be pain and suffering, so please, if you have additional questions, I'm here to answer other questions. So if you want to look at other string functions, we have other string functions in here. Here's str. Here is me using scanf and printf and the various versions of doing this. You'll notice that, by the way, if you didn't, I don't think you have to worry about that part, but you'll notice if you have scanf and I have something like an integer instead of a string, I will need to put an ampersand in front. It's the thing I screw up all the time. The reason you need to put an ampersand, because you need a pointer to the integer so you can change the integer. It's all this pointer stuff. It gives it the power, gives C its power, but it means it's just really hard on the head. But it's absolutely critical part of learning C. Otherwise, why are you learning C? If the thing that gives you all the power, it's like, yeah, again, back to, it's like driving a Ferrari in a school zone, right? You're really not taking advantage of that car. Okay. Can I answer any additional questions? We sort of scratched the surface. We're going to be looking at Cout very, very soon. And we're going to look at things like, hey, anytime I have a string, here's a string object. It looks like another kind of variable. It's not, it's an object. And I can take one of those objects and I can just put a dot afterwards. And it'll give me the listing of all the different functions I can call on it. It's glorious. So here's a string, toTest. The name of the string is toTest. I want to find the letter E in that string. So I call find. I call the letter E. I say, I want to find the letter E in this string, starting at position 0, and tell me where it is. That's where objects come in. That's what we're doing for A to B, which is making a string. Like here is, I'm using a cin statement to put it to, so here's my cout statement. It looks like a printf statement. The message goes out to the cout. I need a new line. It's the end of the line, end of the line. And I keep on having these little arrows that point to where it's going, the cout. I have a cin. It points to the things where it's going into. I take from the user a message that goes into toTest. It is exactly the same. I have the matching thing here. Here is the exact same thing for the two different cases. Actually, it's these 3 lines and these 3 lines. If I want to find a character, I was doing strchr, finding a character. I have to pass in the array that I'm looking for and what I'm looking for. And this says, no, give me the string and call find. Find the E in the string. If I leave off the 0, it still works, by the way. They're all sort of different versions, but there's an exact equivalent or an analogous equivalent in C++ and using strings compared to C strings, these character arrays that we've been using. And if you know one or the other, I want you to be able to see both of them so you can compare and contrast. Because that's when you really know what you're doing, is if you compare and contrast and you can see what the pattern is. That's what we really want to help solidify, or sort of solidify in your head. So I'm going to check for additional questions. I value is a memory location which identifies an object. Is it really? Oh, so the object itself, there's memory location of an object. We'll be using a lot of pointers to objects, and so we'll just do object pointers rather than the in Java and a bunch of other languages. You get an object and it's sort of hidden away that there's a pointer somewhere or a reference to the object somewhere, but it's not hidden away at all in C. You will make an object and you'll get a pointer to that object and you will have a pointer. There's no messing around. It's just straight up pointer. How is the 0 represented in memory? It is literally the number 0 being stored in that array, in that position in the array. Just like null is literally the number 0 stored in whatever pointer you're having. So there's equivalences. The 0 character is actually equivalent to null, which is actually equivalent to 0, which is equivalent to false, which is equivalent, like, it's just numbers, it's just binary under the hood. And at the end of the day, it's how you interpret that binary. If you say, no, that's a pointer, now suddenly instead of being a 0 character, it's a null. It's how you interpret, it's the same number being stored. It's how you interpret it that changes things, which is a bit of a mind trip here for a lot of people. All right. I don't have a lot of new comments from you guys, so can I try and tease out anything else, or are we done? Are we good? Do you want to see other things? What format is in the exam? Okay, although probably better as a Piazza question, but I'll answer it again there as well. So the exam has to be on See You Learn because I'm not going to your house. Sorry. I know you want me to go to your house, but I'm not going to. I refuse. So it's going to be on See You Learn. I tend to now start adding more multiple choice questions. They are not better for you. I will just state that right up front. People, I want multiple choice, they're so much easier. And they get my multiple choice and they go, oh, hell no. Because my multiple choice are nasty. My actual questions are I have a lot of free, you get a lot of partial credit with other questions. Multiple choice, yeah, they suck. Oh, okay. So, I like barbecue. Anyways, multiple choice do tend to suck, but they lead for faster grading, and they also mean instead of when I first came here, I had a whole bunch of essay, longer questions, and I'd get somebody that got a 2 on the exam, and other people that got 100. There would be this huge spread, and it's usually about multiple choice. That person now has 25% because they got a quarter of the multiple choice wrong by just guessing randomly. Yeah, I'm sorry, Ed. 10 to 20 seconds. Oh, shoot. So what we would normally have is some kind of multiple choice to test all of the knowledge that you've been picking up about, what from 1400 or what you've hopefully picked up from the assignment 1. Assignment 2 is also, I do believe it's fair game. So you can think of C strings and strings. I will not be asking about objects or making objects or constructors or anything like that. That will be later. I might ask for a programming question, maybe how to test your code. What is wrong with this code is a big question for me. I like those things as well. Here is a chunk of code. Why am I getting this weird error? Well, although that folds into nicely with a multiple choice question. Okay. Okay, I'm going to go over assignment 1 for us. I'm going to release assignment 1 for sure. I need to release assignment 1. I've just been doing other stuff today, but you're right. I should release assignment 1. We could go over that in the Rusty Rusty student streaming period if we were doing that again this Friday, and see what we go, how we want to do this. But if you guys look at it and go, oh, that's the answer, okay, that's fine, then we can change. Okay. For coding questions, you cannot make nasty long coding questions. The first exam is designed to be answered in a half hour. So if you have a PMC accommodation for double time, you get an hour for it, but it's not meant to be this frantic pace or anything like that. But if you don't know how to code at all, then fairly frantic. But you're not going to be asked to, your code does not have to compile for an exam. I'm expecting most people will have Visual Studio open probably because they want to take advantage of this. But if your code does not compile, pass it in. What I don't want is, I want to be very clear about this one. I don't want people not passing in their code because they're afraid, because it didn't compile, they don't submit anything at all. And I go, why didn't you pass in your code? And you go, because you said you don't have to submit anything for if it doesn't compile. No, that's only for assignments. For an exam, I'm expecting, unfortunately, you guys will have Wi-Fi. and you will have an internet connection, so I cannot give you anything that you can look up online. I also am expecting people to try and cheat, so that's why I'm trying to make sure that you cannot cheat. There will be, randomized questions, all this kind of thing, multiple versions of a question, that sort of thing. We're talking about exam. I mean, the thing next week. The thing next week is what I'm talking about, at least. The final would also be some multiple choice, a whole lot of programming questions, way longer. You get 30 minutes, so I'm hoping to be well under 30 minutes for you to answer it. So if you have, let's say, I'm going to give a random number because I don't want to give the actual number. Let's say you have 4 multiple choice questions and a write this one function. I think that's doable in a half hour, right? Write this one question, write this one function, and give me 2 kind of test inputs that you would use with it, and 6 multiple choice questions, or whatever the case is, 8 multiple choice questions at most. You don't want to have much more than that. But you want to be able to answer it really quite quickly in under a half hour. Most people I'm hoping for be under 20 minutes, but I'm always surprised how long, because no one leaves early, right? You always wait to the last possible second for submitting something. Everyone does. And so that's at least the plan of attack right now for the exam. And yes, Danielle, I can go over and Elijah, I can go over the assignment 1 if you guys want. I'll do that in the Rusty programming class if you want to do that, or we can do it at some other time. I'll also provide the solutions well in advance. It's not all multiple choice, by the way, Stefan. I know there is a lag, 20 to 30 second lag, but I don't think, it seems like people were sort of winding down here. So please, if you have other questions, fire them off now. Otherwise, what I might do is take my leave of you guys and start cooking burgers for my kids. Yes, I have a barbecue too. Haha. It's grilling. I lived in the States. I've been officially, yelled at for calling grilling barbecue. It's a big thing, but if you have technical problems with the internet, so you learn breaking, panic. No, don't actually panic, but I'm going to be trying to be on call. There should be, I think, an on-call number for CU Learn for anything that goes wrong with CU Learn during an exam, that they can be called in. I'm going to try and make sure that they're available, and we figure out something that is fair. For a final exam, it's a really big deal. For a short little exam like this, we can always just prorate stuff. But I want to make sure that it's actually a technical issue, not, make sure you have some kind of evidence that it happened or something like that to be able to justify, like, the power went up for your entire block. Okay, have some kind of evidence that the power went up for your entire block during the exam. If you don't have that, you might be like, oh yeah, my dog ate my laptop, and yeah, we don't want people using it as a way of deferring getting marks for this exam, because exam 1, the whole point of it, the reason it's timed where it is to make sure that people know if they're really falling behind. This is not you guys, I presume, really falling behind in the course and not doing any of the work, and they just show up to the exam. I want them to know to drop right away. You guys have been putting in the work doing the assignment. Even if you thought you didn't understand the assignment, I know you can do it. You've been putting in the time, you've been putting in the effort. That's all I need from you guys. So if you're doing that, you should be fine for that exam as well. Time, date, it will be, I think it's going to be at the start of class time, because it's the only thing I can guarantee that you guys are going to be available for. If you're a PMC student, though, you can schedule other times or have additional, if you need extra time for PMC, that'll all be covered by them, so you shouldn't have to worry about that. It's worth 5%. When do we get A1 marked? They just got it. So A1, they're going to be grading it presumably now. They've had the rubric. We've done the Moss check to see for plagiarism, stuff like that. So I normally give my TAs a week to grade any given exam, any given assignment. So it should be done by the time the exam is there. You should have already done assignment 2, assignment 2A by the time the exam comes, but you wouldn't have that marked. And you can always, and if there's any dispute about the grading, you can always, ask about that, or demand extra points, that sort of thing. We're trying not to be jerks about A1. I know I'd like to talk a tough talk, but I also know you guys are, a lot of you are concerned. If you're putting in the work, I can get on board with being nice about grading things. What I don't want is, if I go nice right away, I'll get a chunk of students that will not do anything until the exam and then complain. So I want the A1 is the shock to the system, if you will. Is there a review or practice? Code crap up. Seriously, if you don't understand pointers, make a bunch of pointers. Like, you can make your own questions. And I know that sounds like a cop-out, but it's amazing what you can, if you're coding up your own thing, like you want to make a linked list on your own without looking at my code example, you will know linked list by the end of that, right? You will flounder, you'll trip up on it, but you will not, there's no point looking at the notes and trying to memorize terms. You got to get your hands dirty. So that, in terms of review, and the lab 3 or whatever it is, I think is also helping with review for the exam. The A2 mini assignment fits in the grading scheme. It's due next week. And, never mind. Okay. Due next week. So 2 little mini assignments, just because they're different from one another. All right. Is that everyone's questions? I'll have to wait a little bit. And let me know if the bit rate went to crap, because I had to go to hardware acceleration on the stream, and I don't know if it went really garbage for you guys. So, keep me informed, I guess. You too, Elijah. A2 does not technically build off of A1. It's all new code, but it is touching a lot of the same things as A1. So it's talking about pulling in things from a file and parsing it. I'm hoping the sample code is helping you, and I don't know, so please ask. If you don't understand something, ask, because I wrote it. I'm like, I'm hoping this is really understandable, but I don't know. So please ask if there's something that's really confusing about it, about how to approach it, because it can get a little, you got to think through before you start coding. Nice. Glad to hear it, Campbell. All right. If that's everything, guys, I will take my leave of you. Thank you very much, guys. Have a great night. What's some great refresher practice videos I should watch? You can watch any of the previous videos that I made, and then I would definitely go and code, not watch videos. All right. Perfect. All right. Thanks, guys. Bye.